This is part 2 of section 2-8 on proving angle relationships. In the first part, I went over all of the theorems and postulates and definitions and proofs that we're going to be using when proving these angle relationships. So this is part 2, and I'm going to do 4 proofs for you. So the first one, we have a diagram, and it's given that ray dB bisects angle ADC. So let's take a look at the picture. Ray dB bisects angle ADC. And if you remember what an angle bisector is it's a ray that cuts an angle into 2 congruent pieces. So basically what that makes me think is that angle 1 is going to be congruent to angle 2. And what I have to prove is that angle 2 is congruent to angle 3. Okay, so before we start to get too concerned about this, let's just state the given. Ray dB bisects angle ADC, and that is given. Okay, so using that idea, let's take it to the next logical step, which I kind of already did. If a ray bisects an angle, it cuts it into 2 congruent pieces, and in this case, those 2 congruent parts are angle 1 and angle 2. If ray BD bisects angle ADC, then angle 1 is congruent to angle 2, and that's by the definition of an angle bisector. What an angle bisector does is cuts an angle into 2 congruent pieces. Okay? And let's look at our picture here. So I have a couple lines here. I have line BD and line AD that intersect each other here at point D, but I'm noticing that angle 1 and angle 3 are vertical angles. So I can actually say that. Angle 1 and angle 3 are vertical angles. And that's by the definition of vertical angles. The definition of vertical angles says that if 2 lines intersect each other, then the angles opposite each other are called vertical angles. So that's definition of vertical angles. Okay. Now notice the definition doesn't say anything about them being congruent. That was actually one of our theorems from the first section. So from this I can say angle 1 is congruent to angle 3 because all vertical angles are congruent. That was a theorem that we had before. So vertical angles are congruent to each other. Now looking at step 2, angle 1 is congruent to angle 2. And then step 4, angle 1 is congruent to angle 3. By substitution, if 1 is congruent to 2 and 1 is also congruent to 3, then angle 2 is congruent to angle 3. And all I did there was substitute. And I've gotten to what I have to prove. Here's our second proof. Given that angle ABE is congruent to angle DBC, that's going to be a little hard to show. Maybe I can draw it anyway. ABE, so that's this angle here, is congruent to angle DBC. That's this angle here. And that's a little confusing because they kind of overlap each other in the middle. I have to prove that angle ABC, this small one right here on the left, is congruent to angle DBE. That's this small one over here on the right. Okay, start with our given. Angle ABE is congruent to angle DBC. Okay, and what I'm noticing is that both of those larger angles contain this one in the middle, a little smaller one in the middle. I'm thinking I'm going to need to use angle addition postulate. And in order to do that, I'm going to need to turn this into an equal sign. And when we do that with angles, we have to say that the measure of the angles is equal. So the measure of angle ABE is equal to the measure of angle DBC. And that's definition of congruent angles. Oops. If the 2 angles are congruent to each other, then their measures are equal. Now, let's get into angle addition postulate here, because big angle ABE is made up of these two smaller angles. So let's go ahead and say that. The measure of angle ABE equals ABC plus CBE. So the larger angle ABE is made up of those two smaller angles. And then let's do angle DBC. The measure of angle DBC, which is our other large angle, is equal to the measure of angle DBE plus the measure of angle EBC. And that is angle addition postulate. Okay. Now, since ABE is equal to DBC, I can do some substitution. If pink is equal to purple, and pink is equal to purple, then this pink is equal to this purple. And the measure of angle ABC plus the measure of angle CBE, that's what I had in pink, is equal to the measure of angle DBE plus the measure of angle EBC. So this is the pink is equal to the purple. And that's by substitution. Now notice, angle CBE is actually the same as angle EBC. CBE and EBC are actually the same angle, and remember we can name angles both ways. So I think what I'm going to do is subtract that from both sides. So I'm going to get rid of the angle CBE and get rid of the angle EBC. And that leaves me with the measure of angle ABC is equal to the measure of angle DBE by subtraction. Between substitution and subtraction, don't ever use just SUB. Use some more letters if you're going to substitute, if you're going to abbreviate substitution and subtraction. Now, notice I'm very close to what I have to prove here, and I think all I need to do is apply one more definition of congruent angles. If the measures of those two angles are equal, then the angles themselves are congruent. And I've proven what I need to prove. Okay, let's try another one. Angles 1 and 2 form a linear pair, and the measure of angle 1 plus the measure of angle 3 equals 180. That's my given information, and I have to prove that angle 2 is congruent to angle 3. So let's go ahead and state, and this one's going to be a little bit different. I'm going to start by stating just the first part of my given. I'm going to split up my given into two different steps. So angle 1 and angle 2 form a linear pair. And that's given. Step 2. If two angles form a linear pair, then we know from one of our theorems that we learned in part 1 that that means they are supplementary. So angle 1 and angle 2 are supplementary. And that was called the supplement theorem. The supplement theorem says that if two angles form a linear pair, then they are supplementary. Okay. Now, let's state the second part of our given, that the measure of angle 1 plus the measure of angle 3 equals 180. And that's given. Now, if two angles add up to 180, then by the definition of supplementary angles, then they are supplementary. So angle 1 and angle 3 are supplementary. And that's by the definition of supplementary angles. Definition of supplementary angles says that if two angles add up to 180, then they are supplementary. And now using step 2, if 1 and 2 are supplementary, and step 4, 1 and 3 are supplementary, then using the congruent supplement theory, I can say that angle 2 is congruent to angle 3. If 1 and 2 are supplementary, and 2 and 3 are supplementary, then 2 has to be congruent to 3. And if you remember from part 1, that was the congruent supplements theorem. And we've proven what we need to prove. And our last proof. It's given that AB is perpendicular to BC, and that angle 1 and angle 3 are complementary. We need to prove that angle 2 is congruent to angle 3. So let's, I'm going to split up our given again just for this particular proof. So let's start with AB is perpendicular to BC. Okay. And if two lines are perpendicular, then they form right angles. Since AB is perpendicular to BC, then angle ABC is a right angle. And that was from the theorem that we did in part 1, that perpendicular lines form right angles. If lines are perpendicular, then they form right angles. Well, if angle ABC is a right angle, then I know that the measure of angle ABC is equal to 90. And that's by the definition of right angle. Definition of a right angle says if it's a right angle, then it measures 90. Okay? And now, looking at the picture, looking at angle ABC, I see that that is made up of angles 1 and 2. So the measure of angle ABC equals the measure of angle 1 plus the measure of angle 2, and that is the angle addition postulate. So two angles that are next to each other add up to the large angle that they make up together. Okay. And now by substitution, here I said measure of ABC is 90. Here I said measure of ABC is angle 1 plus angle 2. So by substitution, I can say the measure of angle 1 plus the measure of angle 2 is equal to 90. And that's a substitution. Okay? So if angle 1 and angle 2 add up to 90, then angle 1 and angle 2 are complementary angles. And that's by the definition of complementary angles. For step 7, I'm going to go back to the second part of my given that says 1 and 3 are complementary. Angle 1 and angle 3 are complementary angles. And that was given. And if 1 and 2 are complementary and 1 and 3 are complementary, then I can say that angle 2 is congruent to angle 3. And if you remember from part 1, that was the congruent complements theorem. And I have proven what I need to prove, that angle 2 is congruent to angle 3.